So today we're going to talk about a couple of more advanced NetLogo constructs, programming constructs. And these are also programming constructs that are very relevant to agent-based modeling because they allow you to kind of do things in a more dynamic fashion than a lot of standard programming that's fairly static, like you write your code and you're done. The techniques we're going to talk about today allow you to kind of create code and make things work kind of on the fly, right? And so that allows you to do things in dynamic ways, right? In ways that might be useful for an agent-based model that perhaps adapts or something along those lines. So the way I'm going to do this, because this is a little complex, I'm going to kind of talk through what's going on, and then I'm going to switch to an example of code, and then we're going to talk through what's going on, and then we're going to switch to an example of code. And for this first lecture, I'm going to talk about the basic idea of what are called anonymous procedures, because everything else we're going to talk about is going to use them in one form or another. And then I'm going to talk, at the end of today, this particular video, I'm going to talk about run, result, which make use of anonymous procedures. In fact, the two are very intricately linked. As you can see, even the first slide on anonymous procedures also contains a reference to run result, right? And then we're going to talk about map and reduce in the next video, which also take use of anonymous procedures. So anonymous procedures have been around in NetLogo for quite a while, but as of NetLogo 6, they actually got that name, anonymous procedures, right? And they became a little more powerful in some respects. And they're kind of a basic concept within NetLogo now. So anonymous procedures are bits of code, procedures, as you might expect, that we do not give names to, but the nice thing about it is we can then pass these procedures around to other procedures to solve more complex problems that we might have in our code. So just to give you an example, here is an anonymous procedure just basically called setup1, which is just going to generate a random number between 0 and 4, right, exclusive. And then another anonymous procedure called setup2, which is just going to return the value blue every time, right? Now, anonymous procedures always, sometimes have these brackets at the beginning. They don't always have to. And then they have this little arrow, and then they have the actual code that runs them. And you'll see many, many examples of them, right? But if you wanted to use them, in this case, what you would wind up doing is you would say you could set setup1 to this piece of code, set setup2 to this piece of code, and then you could ask patches, set color, run result, either setup1 or setup2, right? And so I'll show you an example of that. I'll also show you a more detailed example of an anonymous procedure in just a bit. But essentially what this is going to do is that if you set p color, run result, setup1, it's going to set the p color to 0, 1, 2, or 3 randomly, and if you set it to blue, it's going to set the p color to blue, right? So it's fairly simple, but the nice thing is that now I can kind of build more complex setup routines by having things passed in as to what I want to go on. And I'll show you an example of that. Okay, so here I have a small little code that I'll put up that you'll see below that is an example of doing an anonymous procedure, right? So in the code, if you look at it here, let's blow it up a little bit. We've had we're going to create, just to show you an example of exactly what I did, I'm going to create two globals, setup1 and setup2, that are exactly what we talked about, right? Random 4 and blue. And again, we have this weird arrow thing that basically says we're creating an anonymous procedure here, right? So it stores this not as raw text necessarily or the value of random 4, but rather as the procedure of random 4, right? And so if I run that piece of code, I can do test setup, and then I can say ask patches, set p color, run result, setup1, right? And I get that random pattern of 4 colors, or I can say setup2, and I get all blue, right? So like if we wanted to make this actually into a piece of code, right, we could say to setup given initial task, and task is an old word, it's a shorthand phrase of saying anonymous procedures, and I just don't want to say anonymous procedures. So I call it initial task, right? Clear all, ask patches, set p color, run result, initial task. And then I can have a number of different versions of this. I could have setup 1 and setup 2, which will do this, right? I could do setup uniform initial value, which will just take whatever that value is. So if I do setup uniform blue, that'll be the same as setup 2. And I could do setup random, which is the same as setup 1, right, for instance. And then I created buttons, and as you can see in these buttons, this does setup uniform red, this one does setup uniform blue, and this one does setup random, right? And then setup uniform red, for instance, will take that input as initial value, create a function, an anonymous procedure out of it, and then pass that anonymous procedure to the setup command. Right? So if we hit setup red, we get an all red. Setup blue, we get all blue. Random setup, we get a variety. So the big thing I want you to take away is the anonymous procedure. So far, I've just shown you how to create procedures that take no inputs. Now, in the next couple of examples, we're going to use a lot of ones that actually have something in these brackets because they're going to take inputs. But the big idea is that they're kind of these random pieces of code that, not random, that's not the right word, but they're small pieces of code that don't necessarily have defined functions, but rather can just be passed around to different things. Okay, when I come back, let's talk about run and run result, because those are going to start to get into this a little bit more detail. So run and run result, which you're already seeing a little bit of an example of, both take strings, sets of commands, or anonymous procedures and then execute them. I.e. they take code of some sort, where that code is actually already encapsulated into a procedure, or it's a string that defines a procedure and then runs it, right? The nice thing about run and run result is that we can dynamically create the code that we're going to execute as the model is actually running, right? And that allows us to do very dynamic things, like we have an agent actually change its code over time, right? I should mention, you could pass it a string that's literally like the text of that code, or you could pass it the anonymous procedure. Usually the anonymous procedure is going to be a little bit better because it's already going to be encapsulated into a procedure form, right? The difference between run and run result is that run result will actually return a result, whereas run just executes the code. So for instance here, I'm giving a bunch of commands: run back 1, left 90, right 90, set heading, run result 90 plus. So it's going to actually execute this code and then come up with the results, right? So let me pause and show you a couple of examples of how this is interesting and useful. Okay, so here I have some quick examples of run and run result, right? So this is it's loosely based, by the way, on Melanie Mitchell's Robbie the Robot example, for those of you who have taken the Intro to Complex Systems class that she teaches. So essentially what we're going to do is we're going to generate the code for a robot dynamically during runtime rather than prescribing it ahead of time, right? So you'll see that the turtles own a strategy, which is what moves to take, and a turn strategy, which describes how they should turn. And then there's some commands, there's some globals, which are commands, operators, commands or procedures, kind of operators, and inputs, right? And then you see in the setup, it's going to set the commands to back 1, left 90, right 90, forward 1, right? But you could add as many as you want. The operators are going to be plus, minus, multiply. I don't have divide because divide by 0 can cause you some weird things, and if you accidentally create that could be a problem. And then the inputs are heading, X core, Y core, 1, 2, 10, and so forth, right? And these are all inputs, right? Because they're all numbers, essentially. The heading is a number, the X core is a number, right? So we're going to create 100 turtles. We're going to have them all put their pen down and set their heading to 0, so they're all facing the same way. And then they're going to create a strategy, which is going to be 5 of the commands. And they're going to create a turn strategy, which is going to be some composite of inputs and operators, right? And then the go command is going to say, for each strategy that you have, which is each element, each member of the list of the strategy, create a simple command, which is just to run that command, right? And then we're going to set the heading using run result to the turn strategy. So this is going to say run back 1, run right 90, run forward 1. And this is going to say set your heading to heading plus X core minus Y core or something like that, right? And I'll show you exactly what those pieces of code snippet will look like, right? Now, in this case, we're using this word command, which we haven't seen too much of. Essentially, what that does is take different snippets of strings and kind of paste them together so that we create one large string. And so in this case, we're using a string as the input to run and run results, right? So if we do this, and I forgot to create my little button, so let's do that real quick. Set up and go, right? Now, when we hit setup and hit go, right, it's kind of, they're just moving kind of over the space, and they start out with very simple patterns and they somehow get a little bit more complex. And in fact, if we inspect one of these turtles, right, you can see that this one has a strategy of forward 1, left 90, left 90, left 90, forward 1, right? So that's a very simple command. And then you can see what its turn strategy is, which is x score plus 2 times 1 plus times x score. So it's nonsense, but it was created dynamically. That's the important part, right? Like, it's created randomly. And in fact, you could see how this might be useful in a case where you want them to evolve strategies over time to do something important, right? And by the way, and we're also using, just so you notice right there, there's one of our anonymous procedures, right? So the procedure isn't defined ahead of time. It's just whatever executes this run command execution, right? And it gives the command as the input for each of those strategies. So it's applying that to each one, pulling out each of the elements, and then running whatever it comes out with, right? If you wanted to, right, like, you could see it actually executing if you typed print command as well, right? And this should work. Set up, go. And so now you can see all the commands it's executing as each of the turtles executes them over time, right? Anyways, cool little kind of demo of how to get the robots doing interesting things, to create automatic code, dynamic code, using run and run result.